Hey students, so today we're going to be talking about some different volume formulas. In the previous video, we talked about shapes that have a base area and some sort of constant height to them or length. And the formula for finding the volume of those shapes is the base area times the height. And in today's video, we're going to be looking at shapes that have some sort of base area, but all come to a point at the top. And these are called pyramids or cones. What I have on the screen here is a cylinder and a cone, and each of them have the same size of a base area. I can actually look at the radius apparently is 1, and I can adjust that base area, and it's going to keep consistent for both the cylinder and the cone. And they also have the exact same height. I can adjust that here. And what's interesting is to take a look at how their volumes compare. So at this moment, the volume of the cylinder is 6.6 and the cone is 2.2. And you might notice that the volume of a cone is actually a third of the size of the cylinder, or the cylinder is 3 times bigger. And no matter how you adjust it, if you were to do the math, the cylinder is always going to be 3 times bigger as long as their base area is the same and their height is the same. Now, the same is true no matter what shapes you have that have the exact same base area and height that's the same, where one of them comes to a point and one of them might have a consistent height. Here I have a rectangular prism with a rectangular pyramid on the bottom. And so I could change the size of the base area of each of those. And they actually have the volume formulas here already. Volume of the pyramid is the base area times the height divided by 3. And the volume of the prism is just the base area times the height, no matter how we change it. And the kind of cool thing is you can even move the point of the pyramid around, and it is still at a consistent height. I don't know if you can tell by the diagram, maybe if we adjust this a little bit here, but it is at the same consistent height, and the volume of that pyramid did not change. So no matter what the shape is, basically if it comes to a point at the top, you're going to find the base area and you're going to multiply it by how high it is and then divide by 3, versus the ones that have a consistent height, it's just the base area times the height. And if you want to Google these formulas, that is perfectly fine too, but generally speaking, this is an easy way to memorize them. And here's the names of those various solids here. So basically, things that have a consistent height are labeled with the term of having a prism involved, or just a regular cylinder when it has a circular base. And then ones that come to a point are named with a pyramid. A rectangular pyramid has a rectangular base, a triangular pyramid has a triangular base, and then we have cones. So let's do this first example here. We have a rectangular pyramid, and so that means we're going to find the base area, all right, BA for base area. We're going to multiply that by the height, and we're going to divide it by 3 because it comes to a point at the top. And so the area of the base is this rectangle right here. So that's going to be 10 times 8, which is 80. The height is 6, and we'll divide that by 3. In my calculator, this gives me a volume of 160. And there we have it. So for our second example, I want to review when you have to find a volume in exact form. Notice how we have these ABCD options here that have a pi involved, meaning we have to leave it in exact form. And so we need to find the volume of this cone. We're going to use that same formula. We'll find the area of the base, which is a circle, to start. So the circular area formula is pi r squared, and our radius is, it looks like this is labeling the diameter to be h, so that means our radius is going to be half of that. It's going to be 4. And so we're going to plug in 4 for the radius, multiply that by the height, which is 9, and divide it all by 3. Now we're going to have to leave this in exact form, so we got to do a little bit of reducing here. Pi times 4 squared is going to be 16, and then we'll multiply that by 9 divided by 3. 9 divided by 3 actually reduces to, 9 divided by 3 reduces to 3. And so we'll get pi times 16 times 3, which is 48. And of my options there, I can see that the first one is going to be the correct answer. And that's pretty much it for volume of various solids that come to a point.